Okay, so looking at our next module, starting with 8.1/8.2, these are fairly tied together, just like when we did our factoring, where A was 1 and A was not 1. We tied that all together. So now we're going to take this concept of factoring and now apply it to solving for equations. So our essential question we want to be able to answer by the end of this section, or two sections, is how can you use factoring to solve quadratic equations in standard form? And a quick little review. Remember, standard form is when it is ax squared plus bx plus c, where a, b, and c are our coefficients, and then x is our variable. Alright, so looking at this, a little bit of review from what we've done. So we're just looking at factoring, add in this new concept of going back and looking at it in terms of tiles as well. And so let me get our background up here as close as we can. So I'll use this here, and we'll go, as we look at this, we have an x squared. I'm just going to stack them all up here at the top. And we have 7 x's. And then 6 units, so 6 ones. Alright, so then what we need to do is we need to make this into a square. So as I pull my x squared here, we can arrange these however we would like. And so just for argument's sake, we'll see set them like that, and then if we've done this right, all of these should nicely fit to make a nice square or rectangle, but this one does not, which means the way we've arranged this is incorrect, so we can try some different ways. So I'm going to move this one down here, which means I move those down there, and we're still off. So if I try one more, let's go like that, and as we see there, now I get a nice rectangle, which, as we look at that, across the top, this distance here is x, and this distance here is 1. So we would say this is x plus 1. And then this distance here is x, and then we have 2, 3, 4, 5, 6 ones. So then this would be x plus 6. And so our factors would be x plus 1 and x plus 6, which if we did that as our normal, our AC goes on top and our B goes on bottom, and 1 multiplies to 6 and adds to 7, that would be 1 and 6. We would then put this into our box, and you get x squared and 6, you get x and 6x. So then as we do our GCF, that's 1. So that is x. And then as we go this way, that is x, and that is 6. So you can see we get x plus 1 and x plus 6, which is what we got here, x plus 1 and x plus 6. So it's essentially our area model. If I'd rearranged this, So it looks like this, where that's x and that's 6. As we pull our GCF, there's our 6 and there is our 1. So it's set up exactly the same as we had there before. Okay, so let's look at our next one now. Okay, so look at the next one here. We have x squared minus 10x. So I'm going to use these same ones here. Alright, so now look at our second one here. We have x squared minus 10x plus 16. And so setting this up again. We have an x squared. So I'm going to place this here on the right. You'll see why in a second, because we now have 10 of these x's, but instead of x, they are a negative. So I need to flip all these this way. And if we look at a number line, negative goes to the left, positive went to the right on the last one. So rearranging these as such. Get some this way, some that way. So again, just kind of arranging them however to start, and some of you guys probably see how this is going to go already, but put them that way. And let's get my unit tiles over here. There's our 16 there. As you can see, that doesn't work. So I'm going to move one of these. Up that way. And we're still a little off. So I'll move another one. And we're getting closer, so let's try one more. And that works. So now as we look at what we got here, we have an x here as a distance, and now we're going backwards, so all of these are now negative 1s. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I'd have a negative 8 that way. And then when we go down, that is x, and then I have a negative 2 there. So then we'd say based on that, we have x minus 8 and x minus 2. So let's check with our x box. You get 16 on top, negative 10 on bottom. That means both of these are going to be negative, and 8 and 2 do work. Put that into our box. You get x squared and 16. We get negative 8x here and negative 2 here. So when I go this way, I get a 2, and then that's negative, so I'm going to pull that out. I get x there. Then we go this way and we get x, and this way and we get 8, and that's negative there. Because remember, our goal is to make sure that this multiplies in together. So x times x is x squared. X times, let's say this was just 8. Then what we would have is x times 8 would be positive 8, but I need a negative 8, so I'm going to put that negative there. And then as we check these, x times a negative 2 works there, and then negative 2 times negative 8 is positive 16. So again, we get x minus 8, which we have there, and an x minus 2, which we have there. So just a nice visual representation review for you. X. Alright, so a little bit of extra practice here. Let's work on factoring. So go ahead and try these problems on your own. You can pause here to do this problem. Alright, so we're going to X box here. I have A times C, so that's going to be 2 times 5, which is a negative 10, and then negative 3 on bottom here. So what multiplies to negative 10 and adds to negative 3? It's going to be a negative 5 and 2. Then we can box that, and we get 2x squared minus 5. We get a negative 5x there, and a 2x there. Okay, again, notice 2x squared, negative 5 and 2x is negative 3x, and then negative 5 there. So our box contains what our original equation is. Then we look for our GCFs as we pull out here, so I get negative 5, we get 2x, we get x, and 1. So then we would say our factors of this are 2x minus 5 and x plus, put x, that should be a 1, x plus 1. So let's try the same thing on the second one here. So our A is 1 this time, so 1 times 24 is just 24. Our B is 11, so what multiplies to 24 and adds to 11? It's going to be 8 and 3. And so then we get x squared, 8x, 3x, and 24 here. And then we look for our GCF, so that is 3, that is x, and that is 8. So we get x plus 3 and x plus 8. Alright, so moving on to our new concept. So we can use factoring and what they call the zero product property. To solve quadratics. Now, what the zero product property essentially means is if I have two things multiplied together, so we'll call it A and B. A and B are just variables represent any possible number. But we say that A times B is equal to 0. We know one of three things are possible. We either know that A equals 0 and B equals any number we want, because 0 times a number is still 0. We know that A equals any number, and then B is 0, or A equals 0 and B equals 0. Those are our three options there. So that's what the zero product property means. This means product is multiplication, so we're multiplying two or more things together that equals 0, that at least one of those terms has to be 0. And so that is what now allows us to solve as we head. Alright, so steps to solve by factoring. So one, we want to check for our GCF because our rules of factoring haven't changed. So our first step we always want to do is we want to check for a GCF. Now, as we look at this one, sometimes we have to do step 2 first and rewrite the equation so that it is now set equal to 0. So in this case here, I'm going to subtract a 2x squared. which gives me 3x squared plus 11x equals a negative 6. And then let's add 6. And there's no like terms over here, so we get 3x squared plus 11x plus 6 equals 0. So now it's set equal to 0. Double check, are there any GCFs there? There is no GCF between 3, 11, and 6, and x is not between all of them. So then from there, what we want to do is we want to factor. Okay, so we've done this, so we draw our x. A is 3, C is 6, so we get 18. And then 11 on bottom. And then so answer the question, 1 multiplies 18 and adds to 11. So that'll be 9 and 2. Then we draw our box. And we get 3x, because remember this is the equation we're factoring now, not our original one up here, so don't use those numbers. So 3x squared, we get 9x and 2x, and then our 6 down there. And then let's go GCF, so 9x and 6 is 3. 3x squared and 2x is x. 3x squared and 9x is 3x. And 6 and 2 is 2. So then our factors would be x plus 3 and 3x plus 2. But if you look back over here, remember it is now set equal to 0, which then means we need to set this equal to 0 still. And this is where the zero product property of solve comes into place, as we set each factor equal to 0. Which means we go x plus 3 equals 0 and 3x plus 2 equals 0. And then from there we solve. So subtract 3, and I get x equals 3. Subtract 2, and 3x equals negative 2. Divide by 3, and x equals negative 2/3. So then our solution would be x equals negative 2/3 and 3. And that's how you would solve by factoring. So we factored, which is what we've done before. Then we do our zero product property, which is setting each factor equal to 0. So that is really the only new step coming from what we did in the previous module of factoring. Alright, so a little round robin. The way this is going to work is when we get back into class, we're going to have a quick little discussion about what are the 4 steps to solve by factoring. If you go back to the previous slide, your answers are there, so it should be an easy discussion once we get into class. Alright, so now we're going to solve, so you get a little time to work on these problems here. So go ahead and pause and try these problems on your own to get a little bit of practice, and then I will work these out as well. Alright, so as a quick, we come back, steps, we want to check for GCF. So as we look at the first one there, no GCF on that one, at least that we can see. So on that one, what I would actually want to do is set equal to 0. So I would subtract this 15 over to give us x squared minus 2x minus 15 is equal to 0. Still no GCF. So then from there what we would do is we would factor. So as I factor that one, I get negative 15 and negative 2. What multiplies a negative 15 and adds a negative 2 is going to be a negative 5 and positive 3. Do our box. Make sure to use the end result where it's set equal to 0, so that gives us the negative 15 instead of the positive 15. And then you get negative 5x and 3x. So pull out our GCF, which is negative 5 in that case, x in this case, x in that case, and 3 in that case. So then we would say that so we get x minus 5 and x plus 3. And that is set equal to 0 so that we can solve, which brings us to our last step, which is zero product property, or set each factor to 0, and then after we do that you solve. So in this case we're going to have x minus 5 equals 0, x plus 3 equals 0, add 5, subtract 3, and we get x equals 5, and x equals negative 3. So our answer is here is x equals negative 3 and 5. Okay, so let's now apply that to our second problem here. Okay, so let's start with the second example here. 6x squared plus 5x minus 4 equals 0. So is there a GCF? Nope. It's already set equal to 0 for us, so that saves us time. So then we're going to now just factor. A times c is a negative 24, and our b is 5. So we're going to have a negative and a positive, and that is going to be a negative 3 and positive 8. Let's do our box, and we get 6x squared. We get negative 3x and 8x, and then negative 4 there. Look for our GCF. Here we get 4. There we get 3x. Here we get 2x. And here we get a negative 1. So then we get 3x plus 4 and 2x minus 1. Remember, is set equal to 0. Which brings us to our last step, which is set each factor equal to 0. So 3x plus 4 equals 0, and 2x minus 1 equals 0. Then we want to solve. So on this one I got to subtract 4, and 3x equals negative 4. Divide by 3, and x equals negative 4/3. Then over here I'm going to add 1, and you get 2x equals 1. Divide by 2, and x equals 1/2. So then we would say our answer for this one is x equals negative 4/3 and 1/2. 5 and x plus 3 up here for our first one. Alright, so let's take a look at how this looks graphically to give us a little bit of idea. We showed a little bit of this when we did the activity of will it hit the hoop. And so looking at our first equation that we had factored, and we got x minus 3, or sorry, x. So let's graph that using Desmos here. So we get x minus 5 and x plus 3. And so as we look at this one, so it's set equal to 0. Now what does equal to 0 mean? Well, if we're graphing something, that is as if we wrote y equals x minus 5 and x plus 3. And then what we did is we substituted 0 in for that y value. So where does y equal 0? Well, y equals 0. You can see that blue line there. And where does it intersect our red graph? You can see at the point -3 and at the point 5, which if you remember back to when we factored it, we got the answers of -3 and 5. Okay, and let's try our second one. So let's go 2x minus 1 and 3x plus 4. And then you can see again where it crosses. We have the negative 1.33, which if you write that in a fraction form, that would be a negative 4 over 3. And then we have 0.5, which as a fraction is 1/2. So graphically, that ties into our solving. So we're essentially finding, when we solve, our x-intercepts. Okay, where it crosses the x-axis, which is when y equals 0. So all this will be tied together. We'll jump into graphing more later, but wanted to give you a visual representation of what that looks like. All right, so I want you to reflect, how do solutions relate graphically? Okay. So we'll discuss this when we come back into class, but make sure you have your answer written down. All right, so a little group practice. It's individual practice if you're by yourself on this. So go ahead and work through these problems as well. Alright, so looking at the first one here, GCF, again not set equal to 0, so I'm going to set it equal to 0 to start, so I'm going to add this 54 over, and we get x squared plus 15x plus 54 equals 0. There is no GCF, so I'm going to go ahead and X box this, so I get 50 and 15. And then what multiplies to 54 and adds to 15? Okay, so that would be 9 and 6. Go with our box. We get x squared, 9x, 6x, and 54. Do our GCF, so I get 6 here. We get x there. We get x there, and 9 there. So x plus 6, x plus 9 equals 0. X plus 6 equals 0. And x plus 9 equals 0. Subtract 6. And x equals negative 6. Subtract 9. And x equals negative 9. Alright, let's take a look at our second one now. So this one's a little bit involved, but let's just go through one step at a time. So we're going to get it set equal to 0 to start. So with that, I'm going to add 9x squared over. So that gives me 12x squared. And then I'm going to do a couple different steps at a time. So I'm going to subtract 4x, which then gives me a negative 39x. And then I'm going to subtract 12, which gives me a positive 30, and that is now equal to 0. So check for GCF. In this case, we do have a GCF. So our GCF in this case would be 3. So I factor out that 3, and we get 4x squared minus 13x plus 10. Now, you can deal with this 3 a couple different ways. One way is you divide both sides by 3. That cancels out. 0 divided by 3 is just 0. And you get 0 equals 4x squared minus 13x plus 10. And it's gone. Has no x in it, has no ramifications on what our solution is. The other way is you can leave it there as a factor and then factor it later. And when you try to solve and you set all the factors to it, you end up getting 3 equals 0, which is not true, and that is why it does not impact our answer. Alright, so we'll go with the dividing 3 over. So we'll start with our 4x squared minus 13x plus 10. Go and x factor that. 4 times 10 is 40. And then we get negative 13, which then gives us negative 8 and negative 5. Go for the box here. 4x squared, 10, negative 8x, and negative 5x. GCF here is 2, and we have that negative, so we pull that out. Here we get just x. There we get 4x, and here we're going to get 5, and that negative makes it a negative 5. So then x minus 2 times 4x minus 5 equals 0. X minus 2 equals 0, and 4x minus 5 equals 0, setting each of our factors equal to 0. And then once we do that, we can solve. So in this case, add 2. You get x equals 2. Here I need to add 5. You get 4x equals 5. Divide by 4. And x equals 5 over 4. So then our solution for that problem is going to be x equals 2 and 5 over 4. Alright, so now you have a quiz where you're going to practice some of this on your own. Remember to complete this. This is how you're going to get some of your credit for doing your notes. Okay, this will be posted on Google Classroom, and you can work through it there. We will discuss it and go through those problems from that. Alright, so essential question check-in. So how can you use factoring to solve quadratic equations in standard form? As we saw, there were 4 steps that we work with. We need to set it equals 0. We need to check for GCF. Then we factor, and then we use zero product property, which means we set each factor equal to 0, and then we solve from there. And then your homework assignment, which we'll spend some time in class going over, is here. You have 2 parts, 8.1 and 8.2. Made a lot of it odd, so there's not a whole lot of problems there for you to do.